Hey guys, good morning. How's it going? Or good afternoon or good evening, whatever it is for you guys. This is the tutorials for lesson 8.2, similar polygons. Let's go ahead and work through these together, and this will be the last for the packet. Alright, so number 1, it gives us these two polygons. We have, looks like trapezoids. Draw them out. One fits inside the other, and they are to scale, meaning that they are similar. So number 1 through 6, it says complete the congruence and proportion statements. Number 1, angle D is congruent to what? Okay, so let's look at angle D here. Angle D is the upper left corner for this larger trapezoid. The upper left corner for the smaller trapezoid would be angle H. So that would be the angle that is relevant to angle D. Angle Y, congruent to which angle? Angle Y is the upper right vertex for the smaller polygon, so the upper right vertex of the larger one would be angle R. Number 3, angle T, congruent to what? Angle T is the bottom right vertex, so angle X would be the appropriate vertex there. Now it says sides. So side JD over JH is equal to side DR over what side? So let's look at it. JD is proportionate to JH, so DR is going to be proportionate to the side that is most similar to it, which would be HY. Hang on, I'll be right back. Cat wants to be in the room. Hi, Nina. Number 5, side RT proportionate to YX equals something over JX. So RT is the right side that's proportionate to YX. So then we want a side that's bigger but proportionate to JX. So RT over YX, and that means that JT would be over JX. That's the proportionate side of that one. Number 6, blank over DR equals YX over RT. So YX over RT, blank, so YX is smaller, RT is bigger. DR is bigger, that means we need a smaller side that's proportionate to DR on the top. That's going to be HY. Okay, so that's example 1. Number 7, example 2. It says, are the polygons similar? If they are, write a similarity statement and give the similarity ratio. If they are not, explain. So we've got A, B, C, D. A, B, C, D. This is 20, this is 36. Then I have E, F, G, H. Okay, this is 30 and this is 52. Okay, so remember the two qualifications we need all corresponding angles the same, or congruent, and then we need all corresponding sides similar, meaning they have the same ratio. So these all are right angles, so we knock out qualification 1, all corresponding angles are the same. Number 2, all corresponding sides are similar. So if I put FG over BC, that must equal HG over DC. Okay, so FG over BC must equal HD over DC. That means they have the same ratio. So FG is 30 BC is 20, HD is 52, BC is 36. This here simplifies to 1.5, so this is 3/2 basically. If this simplifies to 1.5, then it's true. It's not. Okay, so check it out. So 18 goes into 36 twice. So this would be 2 times 18. However, 18 does not go into 52. That would have to be 54. So this is not equal to 52 over 36, okay? So part of the question says if they're not similar, explain why. You could just say that these sides are not the same ratio, therefore the polygons are not similar. Alright, next one. We have RSTQ. RSTQ. Alright. 6, 6, and 7.5. And then we have X, Y, ZW. So it's drawn like this, but I'm going to go ahead and flip it upside down because I want these angles to be the same. It'll just help me out visually. So I flipped it upside down. That means this is X, this is Y, this is Z, and that's W. And this was 16, 10, 8, and 8. And this was 12. Okay, let's get crack-a-lackin'. Okay, all the sides, all corresponding angles are the same. So we have double hash marks here on the top angles and single hash marks on the bottom. These are both isosceles trapezoids. Number 2 must say that WX over RQ equals ZY over ST equals WZ over RS equals XY over QT. Okay, so these all need to have the same ratio. Let's go ahead and fill in the numbers. 8 over 6 equals 8 over 6 equals 16 over 12 equals 10 over 7.5. Okay, I can see it right now. This is 4/3, 4/3, this is 4/3, and this is 4/3. Punch this in a calculator. You guys don't always need fractions. So if you do 8 over 6, that should be 1.33. Do 16 over 12, it's 1.33. 10 over 7.5 is 1.33. So they all have the same ratio. Therefore, I can make a statement here that RSTQ is similar to WZYX, and the ratio here is going to be 4. Well, if we're reading left to right, it's got to be 3 over 4. Why? Because the smaller one was on the left and the larger one's on the right. Alright, go ahead and turn the page. A lot of these ones, huh? Are the polygons similar? If so, explain, etc., etc. I'm going to skip number 9. Let's go to 10. Here I've got 2 kites. These actually look like rhombuses. 8, 8, 8, and 8. This is 110, 110. These are similar. This is A, B, C, D. Then I've got this guy. It's on its side. These are the same. This is 70, and this is 70. 10, 10, 10, 10. Okay. The main thing here is just determining if these angles are the same, because I can see right now all the sides have the same ratio. It's 8/10, which is a ratio of 4/5. So let's just determine here if the sides are the same degreeage. If this is 110, that's 110. These are rhombi. Opposite corners are the same. So this must be 70, that must be 70, because 110 plus 70 is 180, and that composes half the rhombus of 360 degrees. This is 70, this is 70, that means this must be 110, and that must be 110. Okay, because this is 70 plus 110, that composes 180, that's half the rhombus. So all angles are the same, all corresponding angles are the same, and all corresponding sides similar. Therefore, these are similar polygons, so we could say that ABCD is similar to, and then you gotta be careful here, we need to rotate this, EFGH, okay? That's because, hold up now. I just did a boo-boo. So the angles must correspond with each other. Okay, I'm going to write this actually as BCDA. This would be EFGH. Okay. Why? Because we have E is a 70-degree angle, B is a 70-degree angle, F is a 110, C is a 110, G is a 70, D is a 70, H is a 110, and A is a 110. So these are same, and the ratio is 4/5. Okay, I'm going to turn my page in another space here. I'll do number 12. Here's our triangle. ABC. That's 3.5. That's 6.3. That's 8.4. Okay, so this next one, it's drawn upside down. It's drawn like this. So we need to draw this the correct way. And in doing so, make sure that your points move as well. E is on the far side. I really just flipped this upside down. Okay, D is still has 3 hash marks, like that. Okay, so right now I can see that the angles correspond. Okay, so that's good. Now I just need to see if these numbers are the same. And for this I'll use a calculator. Oops, that's 4.5. Okay, so let's use a calculator. Oops. That's not how you spell calculator. Let's do 6.3 divided by 4.5. That's 1.4. Okay, so 6.3 over 1.5 is a ratio of 1.4. Next one. Let's go 8.4 divided by 6. That's a ratio of 1.4. And then we'll do 3.5 divided by 2.5. That's a ratio of 1.4. Okay, so both qualifications check out. So they all have corresponding angles and corresponding sides. Therefore, triangle ABC is similar to triangle FED, and the ratio is going to be 1.4 to 1. It's a 1.4 to 1 ratio. Alright, let's move on. Number 13, the polygons are similar, find the value of each variable. Okay, so I would argue these are a lot more simple than the last ones because they take a lot less time. Find the value of each variable, they are similar. Okay, so 10 to 5, that's a 2 to 1 ratio. That means that 8 is going to be twice as big as x, so x equals 4. 6 will be twice as big as y, so y equals 3. I'll move to number 15. Z and y. Alright, so this is a 8 to 4, or sorry, 8 to 6, because this side here corresponds with this side, or it's a 4 to 3 ratio. So that means that, let's see, we can do this two ways. I can do 10 over z is equal to 4 over 3. Okay, so that's using our ratio. And I can solve for z that way, so let's cross multiply. 30 equals 4z. Z equals 7.5. 7.5. Another way to do this would be 4 to 3. If I flip it around, it's 3 to 4. That's a 0.75. That means that these values are going to be 0.75, the full value of these. So 6 times 0.75 would be 4.5. So y is 4.5. And then 12 is 0.75 of x. So I can do 12 divided by 0.75, and that would give me 16. Okay, so we can do the ratios here and cross multiply, or you can just work it with some multiplication and division. Let's move on. Number 17, you want to draw an enlargement of a design that is painted on a 3 by 5 inch card. You plan to draw on an 8.5 by 11 piece of paper. What are the dimensions of the largest complete enlargement you can draw? So your card is 3 by 5. Let's make since it doesn't specify what the height or width is, let's just make it like that. And the paper is going to be a normal piece of computer paper, 8.5. Okay. So really what you want to do is envision which of these sides would fit complete. Which of these numbers would you use to fill up this space more? Okay, so would I use the 3 or would I use the 5? If I use the 5, okay, it kind of looks like this. If I blow it up by 2, I'm almost out of space here. But if I use the 3, here's 3 by 5, that's 1. 3 by 5 is 2. And then up here is the next one. Okay. So I can't, here, I feel like I'm stumbling on my words here. Let's do it this way. 5 over 11 is equal to 3 over y, or 3 over x. So I'm going to fill it up all the way horizontally here, and then when I do that, I'm going to see how much my height goes up. So in other words, I'm going to fill it up all the way to this space here, and then my height should be somewhere around here. Why am I using that? Okay, because I can fit, because the width is longer, I can only put that amount in there, okay? I'm doing a really bad job right now. Let me just do the math, and I'll keep the words to English. How's that sound? So 5x equals 33. We're going to cross multiply. Divide by 5. X equals 6.6. So if I fill up this entire bottom space, if I blow this card up by a factor of 2.2 times, so I'm filling up the entire base, that means that my height is going to reach 6.6 inches. Okay, that would fill up this thing the most. Why did I use the base? Okay, now I think I can show you now. If I use the height, 3 over 8.5 is equal to 5 over x. Let's cross multiply. 3x equals 8.5 times 5. That'll be 44. Okay, no. 42.5. 42.5. 5 by 3. 14.16. Okay, if I were to blow up the height all the way, my base would go outside of the available sheets. You want to use the dimension that basically would be smaller. Let's try number 18. Get another example for this. A map has dimensions 9 by 15. Okay. 9 and 15. You want to reduce the map so it will fit on a 4 by 6 index card. 4 by 6. What are the dimensions of the largest possible complete map you can fill on the index card? Okay, so this map here has 9 by 15 dimensions. I want to fit it on a 4 by 6 card. The base is bigger, so I'm going to run with the base here. I'm going to use 6 over 15 is equal to 4 over x. Okay, so I'm going to fill up the entire base, but the height's going to be a little bit, there's going to be like a border up here. Okay, because a ratio of 4 to 6 is different than a ratio of 9 to 15. This ratio is 1.66. This ratio is 1.33. So it's like, I don't know if you ever play around with a TV. If you're doing aspect ratio, there's a 4 by 3, 16 by 9. If you take an old film that's in a 4 by 3 ratio, and you want to cast it on a widescreen TV, a 16 by 9, you're going to have those borders on the top. That's because the 16 by 9 is actually longer. The ratio of the width to the height is longer than the ratio of a 4 by 3 screen. Okay, so this is basically the same thing that's happening here. We're taking a widescreen image and we're going to put it on just a standard def TV. So we're going to have this border on the top here. So let's multiply this out. 6x equals 60. X equals 10. Is that right? Not 10, 6. X equals 6. Oh, okay. I got 6x, 6 over 15, equal to 4 over x. X equals 6. Something. So I'm taking the big map, I'm putting it on the small one. Pause.